So I'm going to talk about some characteristics in teenagers and what that means for their health in the future. Now this is work that my group have been doing over the last 4 years or so. It's all based on one cohort that we have created, and we're going to focus particularly on, we've been focusing a lot on stress, the way that stress may influence health, both psychiatric disease and going on to the physical. We're going to look at a number of disease outcomes here, ranging from the things like depression through to cardiovascular disease, cerebrovascular disease, and some inflammatory and infectious diseases. As I say, the focus is on stress, but not just stress, because stress has an interplay with other things, other important influences on health, like physical fitness and cognitive function. So here we go. So stress and disease. We talked a lot today and yesterday about psychosocial or emotional stress and how this might cause disease. One can easily see why it might cause psychiatric disease, but the evidence for physical disease is more mixed. And really, to understand disease risk associated with stress, we have to take a life course approach. And the reason for this is usually we're not talking about one exposure and an outcome. It's not like getting an infection and becoming sick. The way that stress is likely to work is through small exposures over many years, which makes sense for something like heart disease. For cardiovascular disease, we know that risks are accumulated slowly over many years. So why adolescence? Well, adolescence is an important time. It's an important time when we can measure things which are relevant both to previous exposure and future health. It's a time of transition from childhood to adulthood. The things that we experience in childhood, the things that we learn, the way we behave, these are characteristics that are established as we develop. But by the time we're teenagers, a lot of them are becoming quite stable, and so they're predictive of how we're going to behave and how we're going to be throughout our adult life. And of course, being a teenager can be quite stressful in itself. It's a time of change. And so an element of anxiety is quite normal. But those who find it really difficult or more difficult to cope with stress, what's going to happen to them in the future? If you just find it that bit harder to cope with stress, will this have consequences for your future health? So we have to think about why this might be. This idea of the stress response that we've been talking about, why it might be problematic. So this is something that's evolved over millions of years to deal with acutely dangerous situations. What we need to be able to do is, if that tiger that we've talked about rushes into the room now, we have to be ready to liberate energy so we can run away or stick a spear in the tiger or whatever else we need to do. At the same time, as we discussed, if the tiger scratches us, we don't want to bleed to death. We want the blood to clot a bit faster. We want it to thicken so that if it attacks, we're more likely to survive. Please don't write in complaining about the picture of a dinosaur with men. I know they didn't coexist. It should have been a tiger, but this is just to illustrate this is a process that's been developing over millions and millions of years, before we became humans, of course. So that's acute stress. It keeps us alive. The acute stress response. We're alive because of it. A car's coming, we jump out of the way. And that's fine. But what is more hazardous to health is chronic stress. If we have that stress arousal, if we have that stress response but don't de-arouse, we stay with that high level of stress. And this is what's potentially much more hazardous for our health. But what actually is stress? Look at these chaps jumping out of an aeroplane. I think they've all got parachutes. But even so, they probably find it fun. Some people would think, actually, that's a terrible thing to do. I couldn't fancy doing that at all. And so this is one of the difficulties, looking at stress. People cope with stress in different ways and are more or less reactive to stress. And so we think about this concept of stress resilience. And this helps us to really understand those individual differences, between individual differences in being able to cope with stress. And this fills in part of the picture. It's not enough just to see looking at stressful exposures. You have to look at susceptibility as well. You know, you could throw some people out of an aeroplane, these chaps would be perfectly happy, others might not be. So this stress resilience, or ability to cope with stress, is another important part of the stress equation. So we need to think about control of the stress response. We know that we inherit characteristics, and what happens in childhood is important. So the more stressful your childhood is early on, the hypothesis is, and it is a hypothesis still in humans, that you are less able to cope with stress. And this is because when you're developing, if you are stress-free, you're more likely to express receptors in your hippocampus and other areas of the brain that can turn down the physiological stress response. So these receptors detect glucocorticoids, stress hormones, and when they detect them, they say, this person's stressed, we do need this level of hormone. So we turn it down, the stress response goes off, you're less likely to have thickened blood, you're less likely to have that raised blood pressure associated with adrenaline. If you have a stressed childhood, you have fewer of these receptors, and so you're less likely, it takes you longer to de-arouse. You say stressed, you're more stressed, and you say stressed for longer if something bad happens. Now, in an evolutionary context, that makes sense. You've grown up in a dangerous environment, and you have to be more ready to deal with stressful events. But it's not so relevant in modern society. You don't need to have this chronic arousal. And this is what we're getting at with stress resilience. This idea of being able to cope with stress and de-arouse more quickly and not have such a high magnitude stress response to a stressful exposure. So it's a complex process, as we've been discussing. Lots of systems and organs are involved. We constantly come back to the hippocampus. It's interesting because the hippocampus is involved in memory as well, and high levels of chronic stress can damage that function potentially. Cortisol is actually neurotoxic. So you don't want to be having high levels of cortisol washing around, damaging parts of your central nervous system. We know that people who have been exposed to terrible stress in a war, they come back and the hippocampal volume is actually smaller. So, you actually lose tissue. So it's a sensitive and important part of your brain. There's a picture of a seahorse here. Why is there a picture of a seahorse? Well, that's because it's a hippocampus. This is the Latin name for the seahorse. It's a hippocampus, and the reason the hippocampus of the brain is called the hippocampus is because if you dissect it out, it looks just like a seahorse. So that's where its name comes from. Okay, so how are we going to look at this? We have done this using Swedish register data. So this is data that have been collected for other reasons, other than this research. And so this is a cohort that we developed for some ICLS projects. And so we've done a number of these now, but this is a specific cohort that we've developed. In Sweden, everyone has a personal identity number, rather frighteningly. I was amazed when I first went there, moved house, didn't have to tell anyone, and my mail was automatically redirected to my new address. So your bank account number is your personal identity number. Your medical records have your personal identity number on it. Absolutely everything does. So this means you have an ID number that can be used to link data together to do research. So there are a huge number of these registers that one can use, covering health and education, all the major life domains. So fantastic resource. One disadvantage is it's not like using secondary data analysis data sets like NCDS or ELSA, because it's a bit like going to IKEA. You get a kit. You don't actually get a finished data set. You order the data with some parameters, everyone born in these years or who have attended military service. And then what happens is you get lots and lots of data sets, and you have to link them all together yourself, and you have to pay for the data. So it's not quite the same, but it does allow you to make tailor-made data sets. I think we've crossed that thermal threshold.
You're allowed to.
I've done my duty, I feel. Right, camera's off now. Okay, so a central part of this data set is the compulsory military conscription data. So it's not the case now, but it used to be that every male would attend compulsory military service in Sweden. The only exempted people were those with a severe disability, or if they were in prison or out of the country. So it's a very complete data set for men. It's only for men, rather than women, for people of this age, or this cohort. And what it contains is lots of information in a standardised way among adolescents, people between 17 and 18-year-olds, including a measure of stress resilience. So I'll come back to this measure, but we have something that tells us about susceptibility to stress. What will that tell us about risk of future disease? So we don't have to think about exposure. We have susceptibility, an indicator of what somebody's stress response might be. So this is all males born in Sweden, effectively, with a small number of loss between 1952 and 1956. So 5 years worth of births of males. So it's around 245,000 who were assessed for military service at the very end of the 60s or the early 70s. So the conscription assessment, in a standardised way, measures things like height and weight, the anthropometrics. Physical fitness is measured using a number of tests, including a brake ergometer, where you get on a bicycle and pedal as hard as you can, and an electric brake comes on and applies you have to apply more and more thrust. Strength, measured in terms of grip strength and flexure. There's a medical history and medical examination. There are 4 measures of cognitive function, and the measure of stress resilience that I mentioned. So, born in the 50s, information on their childhood, their family background from mostly census data, but also from hospital data. And then they were followed up from the 60s, early 70s to 2010, when they were in their 50s. And what we have for the follow-up, we have linkage to causes of death from the death register, all hospital diagnoses, inpatient and outpatient, and actually all prescribed medication as well. But that's only been available since 2005. But that produces a very large data set, to say one thing, but it's a lot of information, useful information. So we should think about this measure of stress resilience. Now, why would the military be interested in seeing how resilient people are to stress, their likely stress response? Well, it's an assessment of suitability for military action. If you're out in a battlefield, some people who respond to stress in a rather unfortunate way might be deemed unsuitable for that sort of service and may end up cutting up potatoes or something. But this is why the military are concerned with stress resilience. So the way it was assessed, first of all, the potential conscripts filled in a questionnaire about experiences and the things that they did. And then there was a semi-structured interview with a psychologist. And this has been assessed. There's a good degree of inter-rater variability, or agreement rather. And the important thing is, although this is about assessing suitability for military service and experiences potentially on the battlefield, because the potential conscripts haven't been to war, they base this on experiences in daily life. So it's what they did at school, what happens when they meet people, what happens when they're in a stressful situation socially. So it's relevant to what happens to people in daily life, even though the military wanted it to assess suitability for military action. So this ends up with a 9-category score, which we consistently divide into 3 categories. So low stress resilience means you find it more difficult to cope with stress. High stress resilience, of course, means you can cope with stress well. So how are these things associated with both short-term and longer-term health risks? We have only a one-time measure, so how stable is it? How predictive is it of things in the future? Suicide. Sadly, one of the commoner causes of death in young men. And so what we see is here are the 3 levels of stress resilience: high, medium and low stress resilience, or the other way around is enough effect. But what we see is that because this is survival, what we see is there's a substantial increase, a hazard ratio of 3.3 for suicide associated with low stress resilience. So a 231% increase in risk if you've got low stress resilience compared with high, adjusting for family background and other characteristics. Now the thing about suicide is there's a peak age of risk. A lot of suicides tend to occur at quite young ages, and then the risk diminishes somewhat over time, or with increasing age. So is this a persistent characteristic? Is this something that tracks out further than age 30, say? So now we'll go right to middle age, looking at stress, resilience, and anxiety and depression in middle age. And we've used the prescription register for this. So people who were treated for depression or anxiety when they were 49 to 58 years old. So this is 30 years or more after stress resilience was measured. So we see a significant increased risk for anxiety, particularly, and for depression. So it is a characteristic that does track across life. Now, we mentioned cognitive function being an important thing that could be associated with stress and stress resilience because of the involvement of areas of the brain like the hippocampus. Important both for laying down memories, important for controlling the stress response. Now, it's well known that cognitive function, better cognitive function, is associated with a lower risk of anxiety, a lower risk of depression. But interestingly, if you look at it in terms of stress resilience, men with low stress resilience who have high cognitive function, that protective effect is lost. So somehow, having low stress resilience knocks out the benefit of higher cognitive function. So we see evidence that this is a persistent characteristic. Low stress resilience has implications for mental health into middle age. So if it has this effect on mental health, what about somatic disease? What about physical disease? Is there evidence that we see an association for that? So one of the first things we looked at was stroke. Stress resilience and stroke. Major cause of neurological disability. And of course, at working ages, as these men were, it can be devastating. So what did we see? We see larger magnitude associations for low stress resilience for hemorrhagic rather than ischemic stroke, so it looks like higher blood pressure may be more important, and for fatal rather than non-fatal stroke. So it's predictive of the more severe outcomes. And so low stress resilience and fatal stroke, you can see a hazard ratio of 2.2, more than 120% increase in risk, not explained by family background. Adjustment for that makes very little difference indeed. But there's a little bit of the association explained by lower physical fitness and higher BMI. So people with low stress resilience tend to be less fit and have a higher BMI. So this is perhaps part of the explanation. But I think we need to look at this in a more sophisticated way to try and understand what's happening in this interplay between stress and physical fitness. And for this we've moved to another disease, a related disease. So ischemic heart disease is the association with CVD, with coronary, with heart disease, mediated by physical fitness. So is that part of the pathway? Is the association altered by stress resilience as well? So is there a mediation through physical fitness? And the second question is, does stress resilience influence how much physical fitness protects you? As we saw with cognitive function. Remember, men with good cognitive function, they didn't see its benefit in protection against depression and anxiety if they had low stress resilience. So what are we looking at here? So this is a number of heart diseases, cardiovascular diseases. We have fatal stroke, fatal coronary heart disease, fatal myocardial infarction, acute myocardial infarction, and angina. So these are the outcomes. And although it's a three-level exposure stress resilience, we're just looking at the highest level of the lowest level of stress resilience, the least resilient compared with the highest. So these are the hazard ratios that tell us there's a significant increased risk for these outcomes associated with low stress resilience, but we did a mediation analysis. And so these blue bits tell us the proportion of the association that's mediated by poor or by physical fitness, lower physical fitness. So let's take fatal stroke. So we have a hazard ratio of 2.11. So that's what this line is equivalent to. And as that's about 100%, you can see that something like 20% is mediated through fitness of this association. A bit more perhaps for acute MI, because remember, this is just a proportion of the whole column. So here we see evidence that partly low stress resilience works through fitness. There's quite a lot that isn't explained by fitness, but fitness is important. Now this idea of effect modification, in other words, does physical fitness have a different effect dependent on your level of stress resilience? So we chop people up into three groups. The highest resilience group, the ones who can cope with stress best, the middle group, and the low group. And so what we're looking at in each of these three groups separately is the association of physical fitness with coronary heart disease. So if you're very fit and you've got high resilience, it's protective. High fitness protects against coronary heart disease. We see a protective effect in the middle group, but interestingly in the low stress resilience group we can see physical fitness, its benefits have disappeared. So if you've got low stress resilience, the fitness isn't as much of a benefit. Now this is fitness in adolescence. And it was eliminated in terms of its protective effect by low stress resilience. Now why might this be? It doesn't mean that you're wasting your time exercising. I think quite the opposite. I think it may be that stress resilience means that if you have low stress resilience, you may be less likely to pursue exercise. You may stop exercising as you get older. It could be that other exposures associated with having low stress resilience overwhelm the benefits of exercise. There are so many other bad things that happen. So this is an interesting and complicated pattern. Stress resilience is associated with being less fit, but also it has an influence on the benefit of fitness too. So what sort of mechanisms? Let's think about some mechanisms now and some other diseases. We've talked about cardiovascular disease and cerebrovascular disease and depression. And one of the things that might be important is chronic inflammation, because this damages health. And we're going to look at this using another set of diseases, gastrointestinal disease, where we know something more about the inflammation. So let's start thinking about fitness first, because we know that poor fitness and chronic stress result in an increased burden of low-grade inflammation. And so this causes damage. If you have inflammation, cells die. And what happens is the cells die and their contents spill out. things like ATP, uric acids, amyloids, cholesterol crystals. And some people call these damage-associated molecular patterns, or DAMP. And this sort of low-grade inflammation and damage can lead to the assembly of the inflammasome. So this is multiple proteins that get tangled together. And the presence of this inflammasome, it's been argued that leads to dysregulation of the inflammatory cascade. This is a long cascading process. People were talking earlier about you throw a stone and something happens a long way downstream through many different stages. And so this low level of inflammation is propagated by dysregulation of the inflammatory cascade, including maturation of some pro-inflammatory cytokines like IL-1 beta and IL-18. So you can think about it like a fire burning in a grate. It's like an ember. If there is that ember glowing away, there's a greater likelihood of it bursting into flame, propagating more severe inflammation. So you can think of inflammation like a fire. Once it's started, it tends to keep going. It's harder to put out. So the way the gut works is, so here are some epithelial cells, here is some mucus, up here is the hole through the middle of the gut where the food goes and the waste. And so what these cells have to do is let the things we want, like nutrients, pass, but keep things out, like bacteria, toxins, some of the large molecules that you don't want. Here's a level of mucus that you have, and here are these little finger-like structures, the villi, which promote absorption. So inflammation can damage barrier integrity. So inflammatory processes mean that things you don't want to get through may be more likely to get through your gut into the cells beyond. Stress has been shown to increase permeability through its action on tight junctions, these bits, these little parts between the cells that hold them tightly together. So there's evidence that stress makes these less tight. And there's an interplay between barrier function and inflammation. So if stress were to increase permeability through its effect on tight junctions, the things that would get through would cause inflammation. Similarly, if there is inflammation in the epithelium or underneath in the lamina propria, this has an influence on the tight junctions. So it goes both ways. So let's start off, instead of with stress, with fitness, and looking at its effect on Crohn's disease. So Crohn's disease is a gastrointestinal disease. It can affect the whole length of the gut, but particularly the small intestine. It's caused by an inappropriate immune response, we think, to the microbiota, the bugs that normally live in your gut. So we usually get on pretty well with our bugs. They sit there, they do some good for us. We give them a place to live. We rub along okay. But in Crohn's disease, the immune system doesn't behave in the way it should and reacts against those microbiota. So you get this inflammation in the gut. Now it's caused by a combination of genetic susceptibility and environmental exposures, we think particularly in early life. But what's important here is it has a long and silent natural history with subclinical inflammation. And we know this from twin studies, identical twins, discordant for Crohn's disease. We have an affected twin, and then if you look at the unaffected twin, who doesn't appear to have frank Crohn's disease, we can see that actually they have low-grade inflammation. So it's a question of something must trigger that low-grade to higher-grade inflammation. So something like another inflammatory insult might just push someone over into more conversion to frank disease, to more symptomatic and unpleasant Crohn's disease. So physical fitness. So we look at Crohn's disease as the outcome. Just under 1,000 of these men had Crohn's between their conscription assessment and the end of follow-up. We looked at a number of factors. We were able to adjust for parental socioeconomic index, household crowding in childhood, cognitive function, chronic disease load, which is assessed in a review of medical records. We talked briefly about markers of systemic inflammation. So here we use erythrocyte sedimentation rate, or ESR, which in the late 60s, early 70s would have been used largely instead of CRP. So it tells you about inflammation, but it's a slightly trickier measure because you need to know about erythrocyte volume fraction to standardize the measurements of ESR and BMI. Now we've taken these, ESR and BMI, as markers of prodromal disease because we know that people with Crohn's disease, as we said, they've got low-grade inflammation for many years before frank onset. So it could be that something's going on, even though there's no diagnosis, that has an effect on perhaps fitness, perhaps on stress resilience. And of course we exclude people who already had Crohn's disease or suspected Crohn's disease, or indeed any other GI disease at the conscription assessment. So here's the interesting thing about the possibility of reverse causation. We're thinking about exercise capacity first. So if you have low-grade inflammation, you may see higher levels of ESR. You may see lower BMI because Crohn's disease and the inflammation associated with it leads to malabsorption. So you don't absorb the nutrients you should from your food, so you're more likely to be underweight. So these are men who did not have a diagnosis of Crohn's at the assessment, but did subsequently. You can see the associations. There's a very substantially increased risk of inflammation, even though these men don't have a diagnosis yet. So this is ESR, the high risk associated with elevated ESR. We can see there's a high risk that they'll be underweight. So it's very important that we adjust for these things, even though they're not perfect measures. ESR is a very insensitive measure to the sort of inflammation you get in Crohn's disease. It'd be much better if we had something like fecal calprotectin, but that wasn't invented then. And so what do we see? So this is physical fitness and subsequent Crohn's disease. Remember, the hypothesis is that if you're more fit, you're less likely to have systemic inflammation and you're less likely to push over somebody who has a tendency to Crohn's disease into frank disease. So there is certainly an association between physical fitness. We see the least fit more likely to develop Crohn's disease, so that would be consistent with some protective effect. However, adjustment reduces this very substantially, and the thing that reduces it are the markers of prodromal disease. And even though they're very poor markers, they have quite a substantial effect. So this is telling us it's probably reverse causation. It's not that being physically fit protects you against Crohn's disease. It's that if you have Crohn's disease, a tendency to it, you're already slightly sick. You already have reduced exercise capacity, and so you're a bit less fit. So it's reverse causation. Physical fitness does not seem to protect against Crohn's disease. What about stress resilience? So here we have low stress resilience, increased risk of Crohn's disease. The association is higher magnitude this time. I've only shown the adjusted results because adjustment makes almost no difference, even when we adjust for these markers of prodromal disease activity. So it looks like this is more likely to be a pathway not confounded by prodromal disease activity. It might work through the stress resilience's influence of inflammation, barrier function. But of course, this could be through behavioural pathways as well as metabolic or immunological effects. But it does suggest this association between stress and the gut. I'm not saying that stress causes Crohn's disease. I don't believe that for a moment. But I think it's more likely to result in the conversion of subclinical disease, which some people might have for all of their life, into frank disease. So that was Crohn's disease, where you had this inappropriate response to normal gut flora. Now let's think about something which is more straightforwardly an infection. Stress resilience and peptic ulcer disease. So peptic ulcer disease, caused by infection by Helicobacter pylori, results in gastritis, in other words inflammation of the stomach, and ulceration. Now if you suppress gastric acid production, this allows healing. It's the gastric acid that does damage and causes these ulcers. Now before the discovery of H. pylori, stress was thought to cause peptic ulcer disease. You know, the medical advice would be, you have to avoid stress if you have peptic ulcer disease. And there's a complex relationship of stress with acid secretion. Some papers suggest that stress increases acid secretion and lowers pH, makes it more acidic, whereas others say actually it's not so much acid secretion. If you're stressed, you're more sensitive to your gastric acid. So that's slightly complex when we think about acid secretion. But what about the association of stress resilience and peptic ulcer disease? So we've got more than 2,000 of these men who develop peptic ulcer disease after adolescence and in adulthood. And we see low stress resilience after adjustment, this increased risk of peptic ulcer disease. So stress is associated, or low stress resilience is associated with an increased risk. So why might this be? We're seeing an increased risk of mucosal damage. Is it because of the effect on Helicobacter pylori, the ability of the body to deal with H. pylori? Is it impaired immunity? Is it acid related? Is it damage, or is it even sensitivity, so that people with low stress resilience, they have symptoms and they're more likely to seek medical advice? But again, we see associations of low stress resilience with gastrointestinal disease. So that's an infection. So let's have a look at another infection. Salmonella and stress resilience. So if low stress resilience is associated with impaired barrier function, as we think might be the case, and mucosal immunity, and we see it associated with H. pylori, what's going to happen with other infections like salmonella? So gram-negative bacteria quite often results in hospital admission, population level. 602 of the men in the cohort during follow-up after exclusions had salmonella infection, serious enough to be admitted to hospital. Usually you catch it because you've eaten some infected food. That's the most common way to get it. So this is an intracellular pathogen. The way that works is it infects a cell to reproduce, usually. So if you ingest salmonella, to be really sick, what has to happen is it has to get past that intestinal barrier. It's got to get through the mucus, got to get through the cells, perhaps bypassing loose tight junctions, and then infect a cell, or infect many cells, and start producing endotoxin, this chemical that makes you sick. So if low stress resilience increases risk of salmonella infection, that would be consistent, wouldn't it, with what we see with a putative influence on barrier function. And so what do we see? Here's stress resilience and salmonella infection. Here are the most resilient, here are the least resilient, the most susceptible to stress. So the hypothesis was completely wrong. It's completely the other way around. Which is great, isn't it? It's rather nice, because all these things associated with low stress resilience, finally, it's the other way around, which is unexpected and perhaps initially disappointing. And it's the sort of thing that makes you go back and say, shall we just check that again? Have we coded the variable the wrong way? But no, it looks like, and this is consistent actually across a huge range of GI infections. So impaired immunity or barrier function, that doesn't seem to be a very likely explanation. And this is in contrast with almost every other infection we've looked at. Most infections we've seen are the association is the other way around. So something peculiar or different is going on for these gastro or enteric infections, the intestinal infections. It's the wrong way around. So the more stressed you are, the more protected you are, the less likely you are to have these infections. So why should that be? Well, maybe we can have a clue from peptic ulcer. Because, gastric acid is one of the things that provides important defense against salmonella and other enteric infections. So the acid in your stomach, it sterilizes the food you eat. So some of these bacteria die at low pH, at the more concentrated levels of acid in your stomach. So perhaps we can have a clue by looking at peptic ulcer disease. Because after diagnosis of peptic ulcer disease, what usually happens is that proton pump inhibitors are prescribed. So these are things that suppress acid production. So you go from having high acid production to very low acid production. So do we see an inverse association of peptic ulcer disease with salmonella? So this is a time-dependent covariate in this analysis. So it switches on after you've had your diagnosis of peptic ulcer disease, which means you're almost certainly having proton pump inhibitors, which means you'll be producing much less gastric acid. And what do we see? Those who have had a diagnosis of peptic ulcer disease and almost certainly are treated with proton pump inhibitors, they're at greater risk of salmonella infection. So low stress resilience means increased peptic ulcer disease risk, which would mean increased acid production, so lower salmonella risk. So this is before a diagnosis of peptic ulcer disease. So this would make sense. We know that low stress resilience means you're more likely to have peptic ulcer disease. Most people won't have a diagnosis of peptic ulcer disease, but they may be producing more gastric acid. So perhaps this is the mechanism. Low stress resilience, more gastric acid, and you're protected to a certain extent against infections like salmonella. What happens after the peptic ulcer disease diagnosis? Less production of gastric acid and this increased risk. So diagnosed peptic ulcer disease is associated with an increased risk of salmonella infection, possibly due to this low level production after proton pump inhibitors are prescribed. But this surprising finding, low stress resilience is associated with a reduced risk of salmonella infection, perhaps because when we are more stressed, we produce more gastric acid. So this could be part of the stress response, protecting us from infection at times of higher risk, including this sort of infection, enteric infection. So stress resilience does seem to matter in terms of what's going to happen in the future. There are lifelong consequences of low stress resilience for cardiovascular disease and other diseases with an inflammatory etiology, like Crohn's disease. There are adverse consequences if you have low stress resilience for the benefits of cognition and fitness. They lose some of the beneficial effect if you have low stress resilience. The association with gastrointestinal infections is rather more complex. But what should we be thinking about? What really matters here? Well, we need to think about the things that influence the development of stress resilience. We know it's important. What influences it? We think childhood environment matters, although there's still some uncertainty about the precise things in childhood and when in childhood they have their greatest effect. So that's actually our next big cohort project. We're just developing a new cohort now, this time with 7 million children in it, and we're going to look at the other end of life. So this one was really looking from adolescence on into middle age. What we're doing in the next project is looking from pregnancy through to adolescence. So the outcome is going to be stress resilience and other measures that tell us about stress-related physiological responses more specifically. So what does this mean? We probably have to promote good health in adolescence through both physical fitness, and that does matter, in contrast with what the Daily Mail said when it reported the paper on the effect of stress resilience and fitness. Fitness does matter, it matters even more, and perhaps it's going to have its greatest benefit in people who are able to cope with stress better. So we have to think about both physical fitness, perhaps, and coping with stress. And so acknowledgements, a lot of this work, but not all of it, was PhD projects. So thank you, my PhD students, but other collaborators, and funding from the ESRC. This cohort was developed through work as part of the ICLS, the International Centre for Life Course Studies. Örebro University put in a reasonable amount of money as well into this research, and specific projects have been funded by Folksam and Olli Enquist's Stiftelse. Thank you.
Great.